So this one's actually also something we've already talked about before, but it's always good to talk about it again because there's a lot of different things going on. So on our last assignment, a lot of those roots worked out very nicely, like there actually was a square root of that number and stuff. This one, not so much. You're just going to have to simplify it as much as you can. Okay, so a couple things. Remember your product property of radicals. If you have the square root, for example, of two numbers multiplied together, that's the same thing as splitting it apart into two separate square roots. Okay, and same thing with whenever you have the quotient, right? If you have the square root of two different things divided, it's the same thing as the square root at the top divided by the square root at the bottom. So just a couple rules that, again, you've already used before. If I was going to work question number 1 here, this is where you are going to have to actually do your little factor tree. So 54, there's a lot of different factors of 54. The one that I personally would like to use is just 9 and 6. Okay. Now remember the cheat here. Okay, we've talked about a couple things. I don't know how much you remember, but I actually know the square root of 9. So I could just go ahead and pull that 3 outside, right? Square root of 9 is 3, so that means that 3 is going to come outside. Now, if you don't see those kind of things right off the bat on your own, that is okay. Go ahead and keep simplifying this out. Find all your factors, and then look for your pairs. Okay, I have a pair of 3s, so that means I'm going to bring a 3 to the outside. I have an extra 3 and an extra 2. Those two multiply together and stay on the inside. So on the inside, I'm going to have a square root of 6. On the outside, I have a 3, but I already had a 5. So I'm going to multiply those two together to get 15 square roots of 6 for my answer. Okay. Same exact thing on question number 2, but I'm looking for groups of 4. So again, I could factor tree out 32. 32 is 16 times 2. Again, if you know 16 is actually a perfect fourth root of something, you could stop there. If you don't know, feel free to carry on. That's 2 times 2 times 2 times 2. So right there's my group of 4 2s. So I know I'm going to have a 2 on the outside. I know I'm going to have one extra 2 on the inside. I'm going to skip a little space there because I know I'm going to have some letters out there. My little 4 has to stay, and I know I have a 2 inside. What about the letters? If I have 9 A's, how many groups of 4? Okay, well, I could write it out again if I wanted to. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's first 4, second 4, 1 extra. Okay, so I could do the same thing here. You just really shouldn't have to. The easiest thing is to just say, how many times does 4 divide into 9? That's 2. So that means I'm going to have an A squared on the outside. How many remainders do I have? 1 extra A stays inside. I could do the same thing with the B's, because I definitely don't want to have to write down 20 B's. I just know 4 goes into 25 times, so I'm going to have a B to the 5th on the outside, and that is going to be my answer. Doesn't it look nice and simplified and reduced? That's sarcasm, by the way. Same thing with this one. 75. I know 75 is 25 times 3. Again, if you see that, here's a perfect square. I know that means I'm going to have a 5 on the outside. If you are not comfortable with that, again, feel free to factor tree it all the way down. You will find that you have 2 5s and an extra 3. 5 on the outside. I know I'm going to have a 3 on the inside. Okay, x to the 4th, the square root of x to the 4th. Again, if I have 4 x's, I have 2 groups of 2. So that's x squared. Y to the 7th, if I have 7 y's, then I have 3 groups of 2 with 1 extra. I feel like I'm writing really small, so I hope you're able to see that okay. Question number 4 is an excellent one. So this is one where our quotient property of radicals comes into effect. I can just simplify this as the square root of 36 over the square root of 125. Now you could reduce 36 over 125 first if it reduces, but this one doesn't. Okay, so it's easiest just to do it this way. The square root of 36 is 6 on top. Square root of 125, that's 5 times 25, which is 5 times 5. So I have a pair of 5s and I have an extra 5. So 5 square root of 5 is technically a lovely answer. However, if you remember, we've actually simplified questions like this before. We really don't like to leave square roots in the denominator. We just don't. It's considered sloppy. It's considered just not simplified. Okay, so the way we would get the square root out of the denominator, if you remember, you might have to think back a little bit, is to multiply the top and the bottom by that square root. Okay, if I multiply both of those by the square root of 5, the top becomes just 6 square roots of 5. The bottom, okay, here's a square root of 5 times a square root of 5 is just 5. 5 times 5 would be 25. So this is actually considered a little more simplified. I'm not sure, I'll have to look again to see what is expected of you on your test. Okay, so same thing here on number 5. I could simplify just the top, a to the 6th, b to the 3rd, and then simplify just the bottom. Okay, that seems to help people is to think about that. You might be able to do it all at once. It's a little ambitious, but do what you need to. Square root of a to the 6th is a to the 3rd. 1b is going to come outside, and I have 1b stuck inside. Okay, 98. Well, that's 2 times, 49? 49 is 7 and 7, so I know I'm going to have a 7 square roots of 2. Okay, again, this is technically true. Okay, if you were going to simplify this a little more, again, I do not like having square roots in the denominator, so the way I would simplify it is by multiplying both the top and the bottom by a square root of 2. Okay, that would make the top a cubed b square root of 2b. Notice how square root of b times the square root of 2 is the same thing as the square root of 2b. I could put those together under one square root. On the bottom, again, square root of 2 times square root of 2 is just 2. 2 times 7 would be 14. Sorry that got so crooked. All right, same thing on this next one, okay? So again, I could split this up top and bottom. What is the cube root of p to the 5th, q to the 3rd, over the cube root of 40, okay? Well, this one might blow your mind just a little bit. So the cube root of p to the 5th, that's not too bad. I know I'm going to have one group of 3, right, with 2 extras inside. Okay, q's, I have one group of 3, so that can come outside. On the bottom, I'm going to have to factor tree out 40. That is 5 times 8. 8 is 2 times 4, 2 times 2. So here is a group of 3 2's. I know I'm going to have a 2 on the outside. I know I'm going to have a cube root of 5 on the inside. All right, so again, that's technically true. If you were going to clear out the radical on the bottom this time, okay, notice here, I just multiplied by square root of 2 and square root of 2, or square root of 5 and square root of 5, but I cannot this time just multiply by, and I wished I had more room to write this, I can't just multiply by the square root, or even the cube root of 5, because if I multiply by the cube root of 5, that's just going to be the cube root of 25, right? 25 doesn't have a cube root. So the thing is, I need to multiply this by the cube root of 5 squared, or 25 if you prefer, because then I would have a 5 times a 5 times a 5, or I would have 3 sets of 5, so they could all come outside. Okay, so if you did that, the top part would just become p, q, and then the cube root of, I'm going to go ahead and say 5 squared is 25 p squared, all over, and then the cube root of 5 times 5 squared, okay, would just be the cube root of 125, which is just 5, so 5 times 2 would be 10. Okay, so there are some circles that would say that this is much more simplified than this. We just really don't like having those radicals in the bottom, okay? We'll talk to you about how it's expected on your homework, but they also do it up here on this problem, okay? All right, so I guess I'm just going to keep going. Sorry, that's going to make this one video kind of long, okay? But again, we've done all this before too, okay? When you're adding radicals, remember they have to be the same. They have to have the exact same number under the exact same type of root for it to work, okay? So the first thing I need to do is simplify this. I know that 50 is 25 times 2, so that's just going to be 5 square roots of 2, okay? I know 8 is 4 times 2, so that's just 2 square roots of 2. So if I simplified this, 3 square root of 2 I cannot simplify. That's done. This one, again, I have a pair of 5s and an extra 2, so that would be plus 5 square roots of 2. This, I have a pair of 2s and a 4 that was already outside. Those multiply together, so negative 8 square root of my extra 2. Okay, so since these do all have the same type, okay, those are almost like variables in that they have to be exactly the same for you to be able to combine them. These are, so 3 plus 5 is 8, 8 minus 8 is 0. What a fun question, right? Okay, so the same thing on this next one. I'm going to skip a couple steps because I know my square roots pretty well, right? 20 is just 4 times 5, so that's going to be 2 square roots of 5. 125 is 25 times 5, so that's going to be 5 square roots of 5. And 45 is 9 times 5, or 3 square roots of 5, okay? If you didn't see how I did that, just do your traditional factor tree. I know you know how to do that. Again, these are all the same. So I can combine those. 2 plus 5 is 7. 7 minus 3 is 4. So 4 square roots of 5 is your solution. Okay, same thing in the next one. I know that this is 3 times 100, so that's going to be 10 square roots of 3. I know that that's 9 times 3, so that's going to be 3 square roots of 3. I know 75 is 3 times 25, so that's going to be 5 square roots of 3. Again, I combine these. 10 minus 3. Again, check those roots. They're all the same type. 10 minus 3 is 7. 7 minus 5 is 2. 2 square roots of 3 is your answer. Okay? Remember, when you are multiplying radicals, you could do a couple things here. Okay? So, options. You could simplify this first. Okay? You could simplify this one, and then multiply them together. Okay? You could just multiply 81 and 24. Okay, I personally like to kind of take a shortcut and say that this is the same thing as the cube root of 81 times 24, and just factor tree from there instead of literally multiplying the numbers 81 and 24. So 81, that's 9 times 9, 24, let's say 2 times 12, that's 2 times 6, which is 2 times 3, 3, 3, 3, 3. Again, I'm looking for groups of 3 because this is a cube root. So right here, here's 1, 2, 3 threes. Here's 1, 2, 3 twos. I have an extra 3 and an extra 3. Okay, so the 3 and the 2 multiply together to come to the outside, so that's 6. My cube root stays. My extra 3's multiply together to be 9. So 6 cube roots of 9 is your solution. Okay. On the next one, when you have something like this, again, you could factor tree this out and see if anything happens. This one doesn't have anything that happens. And see if you can add those together. Okay, if you can, that might make this a little bit simpler. These are not going to add together though, so we just multiply. So again, you could say that this is the same thing as the cube root of 8 plus the cube root of 24. Okay, notice what I did there. Just the 2 times the 4, 8, 2 times 12, 24, and then simplify from there if you want. Okay, you can also simplify one at a time, however you want to do it. But I know the cube root of 8 is just 2, plus I know 24 is, again, I just did this one, 2 times 12, 2 times 6, 2 times 3, so a group of 2's. So that's 2 cube roots of 3. And that is as simplified as that gets, because I cannot add this to this. Can't add those numbers together because this one's attached to that, so I am done. Okay. Same thing on this next question. Okay, so I'm going to do this again. That's going to be 2 times the square root of 3 times 15 is 45, plus 2 square roots of 3 times 6 is 180. So that's one way to do it. Again, there are multiple ways to look at this. Okay. 45 is 9 times 5. I know 9 is a square root, so I can pull that out. That's going to be 6 square roots of 5. Plus, I know 180 is, I think it's 180. I could do 18 and 10, but again, I kind of like to find those perfect square roots. This is 36 times 5. 36 is a perfect square root, so I know that that's just 6, but I had the 2 already out there, so 12 square roots of 5. And oh boy, look at that. I could actually add these together, which actually means maybe if no, I couldn't have done that. I can't actually add these together though. So 6 square roots of 5 plus 12 square roots of 5 is just 18 square roots of 5. Giving you a second to see if you can figure that out yourself. Okay. So again, I feel the need to apologize with the length of this video, but we're just going to keep trucking. There's a lot of different rules here, okay? So a question like this definitely looks like FOIL because you're going to have to FOIL. So let's do that. 2 times 4 is 8. 2 times the square root of 7 is just 2 square roots of 7. 3 square roots of 7 times 4 is just 12 square roots of 7, okay? 3 square roots of 7 times the square root of 7 is just 3 times 7, or 21. Okay, again, I can combine some like terms. 8 plus 21 is 29, plus 2 square roots of 7 plus 12 square roots of 7 is 14 square roots of 7, and that is as simplified as that question gets. Okay, same thing on this next one. So here we go. 6 square roots of 3 times 3 square roots of 3. Okay, that 6 times 3 is 18. The square root of 3 times the square root of 3 is just 3. So 18 times 3 is 54. Okay. 6 square roots of 3 times the square root of 2 is just 6 square roots of 6. See what I did there? Square root of 3 times the square root of 2, square root of 6. Okay. So same thing when I get ready to do this one right here. Negative 4 square root of 2 times 3 square root of 3 is a negative 12 square root of 6. Negative 4 square roots of 2 times the square root of 2. Again, that's negative 4 times 2, or negative 8. Again, I could simplify this by combining like terms. 54 minus 8, 46. 6 square roots of 6 minus 12 square roots of 6 is a negative 6 square roots of 6. And again, that is as simplified as that question can get. All right? Okay. So on this next one, one thing that actually might make this just a tiny bit easier is to first simplify this question. Now, if you did not see that that's simplified, then that's okay. What you got would work out just fine, and it wouldn't really make that much of a difference. But I personally find it easier to simplify this first. Okay, so that's 4 times 5, which means I actually could pull an extra 2 out there. So that turns this question into 4 square roots of 2 minus 3 square roots of 5 times 4 square roots of 5 plus 5. Okay. Sorry about that. Okay, again, I'm going to FOIL this. 4 square roots of 2 times 4 square roots of 5 is just 16 square roots of 10. That's not going to simplify. 4 square roots of 2 times 5 is just plus 20 square roots of 2. Negative 3 square roots of 5 times 4 square roots of 5, and this is where it saves you just a tiny bit of time, because that's negative 12 times 5, or negative 60. And then negative 3 square roots of 5 times 5, negative 15 square root of 5. None of those are like terms, and I cannot simplify any of them further, so that is completely done. Okay. All right. I'm going to keep going down here. On this next question, again, we've actually looked at questions like this before. I'm going to trade papers because it was just my work was getting sloppy. A couple things you could do here. If I had this question right here, the very first thing I would do is I would simplify anything on the top you could simplify. For example, you know 75 is again 25 times 5. So this is just 5 square roots of 5. Okay. 48 is 16. I think 48 is 16 times 3. So this I could simplify as 20 square roots of 3. So let's rewrite that way. 20 square roots of 3 plus 5 square roots of 5, all divided by 5 square roots of 3. Okay. So there are, again, several things you could do here. We could start by trying to clear out the square root out of the denominator if you wanted to. I can't combine these top things because those are not the same square root. But look what you have here. You have a 20, a 5, and a 5. Okay, so one of the easiest things to do would be to go ahead and simplify all those by 5. That turns this question into 4 square roots of 3 plus the square root of 5, all divided by the square root of 3. Okay, now again, this is technically a true answer, but we don't like to leave those square roots in the bottom. So I am going to multiply this top and bottom by the square root of 3. When I do that, the bottom just becomes 3. The top, I'm going to have to FOIL that out through there. 4 square roots of 3 times the square root of 3 is just 4 times 3, or 12. Square root of 3 times the square root of 5 is just the square root of 15. That doesn't simplify anymore. Now, don't get crazy and be very, very tempted to divide both of these numbers by 3, because they do divide by 3. You can divide the 12 by 3, so you could simplify that to a 4 if you wanted to, but you would have to leave the second number as the square root of 15 over 3. I personally do not find this any more simplified than this, so I would suggest leaving this answer like that. Okay? You cannot divide the 15 by 3 even though it is divisible by 3, because the 15 is stuck under that radical. Okay? This next question, we've seen questions kind of like this before. Again, if I'm going to clear the square root out of the denominator, okay, I'm going to have to multiply this by its conjugate, which is the exact same thing with the opposite sign. Okay, remember when you do that on the bottom, that creates a perfect squares down here, a difference of 2 squares. Okay, so you can FOIL it out if you don't believe me, but what's going to happen, you're going to do the 2 times the 2 is 4, right? And then when you do this other, that's 2 square roots of 2 minus 2 square roots of 2, those cancel, okay? Negative square root of 2 times the square root of 2 is just negative 2. So the whole bottom simplifies to just be 2. That is the whole reason why we multiply that by that specific term, that just changing the sign on it, okay? Because we know that that's going to make those square roots cancel out. For the top part, I am going to have to FOIL this out. So 4 times 2 is 8. 4 times the square root of 2 is 4 square roots of 2. 2 times the square root of 2 is 2 square roots of 2. Square root of 2 times the square root of 2 is just 2. When I simplify that and combine like terms, that's 10 and 6 square roots of 2. Okay. This one I can simplify because there's a number out here and out here. All 3 of those numbers are reducible by something, 2 in this case. So that's just 5 plus 3 square roots of 2. Very last question, you're going to work the exact same way. Okay, so I'm going to multiply this by its conjugate, which is just 1 plus 2 square roots of 3. Have to do it to top and bottom. Again, when you FOIL out that bottom, the middle term's going to cancel. So you're going to have 1 minus, and then 2 square roots of 3 times 2 square roots of 3 is 4 times 3, or negative 12. So the bottom simplifies to just be negative 11. Okay. Again, for the top, I'm going to have to FOIL that out. 5 times 1 is 5. 5 times 2 square roots of 3 is 10 square roots of 3. 3 square roots of 3 times 1 is 3 square roots of 3. 3 square roots of 3 times 2 square roots of 3 is 6 times 3, or 18. Again, when I combine like terms, 18 plus 5 is 23. I'm going to come down here and write it 23. Plus 13 square roots of 3 all over negative 11, and quite honestly, that's really as simplified as that one gets. Sorry that this video is so long. There's a lot of different things to talk about.